all. There you go. So welcome you, and it is a great pleasure to see so many of you joining us online and those present here. My name is Federica Sulas. Together with Nick, pediatric surgeon, we've had the privilege of organizing seminars for this term. This term seminars will be hosted in a hybrid format, so online streaming from the seminar room of the McDonald. And before I introduce the seminars of today, I would like to welcome, to thank the Department of Archaeology, its Research Committee, and the McDonald Institute for welcoming our proposal and sponsoring the seminars. Now, enthused by the Garrod seminars presented in the previous terms this year, this spring the series explores the historical ecologies of scales through a cross and transdisciplinary journey that engages the past to inform the present. The choice is not casual and indeed inspired by the contribution of Dorothy Garrod to interdisciplinary research and engagement with local communities. And here on the screen, you can just about see a view of the first excavation she masterfully directed in Mount Carmel with a formidable crew of different specialists and bonding relationships with local communities. We have an amazing, very exciting lineup of speakers who this term will offer historical ecology contributions to the potentials and challenges of different scales of research and community engagement through a focus on place, epistemologies, resources, and communities. I encourage you to check our program on the department website, where you can find abstracts and full information. Now, Nick and I are absolutely thrilled to welcome our speaker today, Professor Roland Fletcher, joining us from late evening Sydney, Professor of Theoretical and Water Archaeology at the University of Sydney. Professor Fletcher, before moving to Australia, attended St. John's here in Cambridge and spent months examining living space in a West African village to complete a massive 2-volume PhD thesis. And straight after defending the thesis, moved to Australia at the University of Sydney. And this was just really the beginning of a long and exceptionally prolific and influential critical thinking on settlement, its nature, form, and dynamics across cultures. His 1995 book, The Limits of Settlement Growth, published by Cambridge University Press, has transformed really our understanding of urbanism, and later publications spanning comparative approaches to urbanism, water, resilience, and so much more have been advancing theoretical, analytical, archaeological approaches. His cross-disciplinary collaboration at Angkor in Cambodia engages with universities worldwide, the Cambodian government agency that manages Angkor, and with the École Française d'Extrême-Orient. This collaboration developed into the University of Sydney's Greater Angkor project, of which Professor Fletcher is the director. He's been a distinguished fellow of Durham University's Institute of Advanced Studies and an annual resident fellow at the Danish National Urban Networks Center. Invited speakers at the Falling Walls Conference in Berlin, several keynotes down the line over the years, including at the Shanghai World Archaeological Forum. He's currently continuing his research on the history and spatial dynamics of settlement patterns, focusing on low-density settlements. And without any further ado, I'd like to invite Professor Fletcher to share his screens. He's taking us to Southeast Asia, but across really a global perspective. Thank you, Professor Fletcher. The floor is yours if you want to share your screen.
Thank you very much, Federica. Thank you for the invitation. It's an honor to be speaking in a lecture series respecting Dorothy Garrod, who was a real pioneer in archaeology in very many ways. What I'm going to do today is to talk partially revolving around Angkor, but looking more broadly at the issue of low-density urbanism. And I'll focus initially on low-density urbanism in the pre-modern world. And then at the end of the presentation, I'll come on to the implications of that information for the present that we are now confronting. Somewhat unusually, in the talk on low-density urbanism, I'm going to start briefly by a comment about compact urbanism, because it's the contrast between the two which becomes very serious when we're looking at the resilience or the lack of resilience in low-density urbanism, the implications of that for the modern world. The key point I want to make, I'll do it very briefly, is that the networks of compact urban settlement systems are extremely robust. One of the classic examples is in Europe in the period after the end of the Roman Empire. We're dealing with standard compact settlements, typical Roman, post-Roman towns. When you look at the political pattern of Europe from 400 to 800 AD, you're going from a consistent, singular, cohesive control with lots of marginal, changing, fluctuating cultural systems and political systems to this extraordinary mess. For 400 years, there was extreme socio-political instability in Europe. Laid on top of this, of course, are the great migrations and the destabilizations which they caused. But in the midst of all this socio-political change, there is no significant change to the urban network system in Europe. There's a notable study in 2016 by Michaels and Rauch, which shows the degree to which the French and the English urban systems display substantial continuity from the Roman through to the medieval, and in fact through to the modern world. Such a degree that Michaels and Rauch actually remark that some French cities are now in the wrong place, because essentially they're in the right place of being in the Roman Empire, which just doesn't happen to be around anymore. If you look at the UK, the shift from the Roman to the Anglo-Saxon system involves a great many changes in the specific nature of settlements, and it involves the demise of some settlements. So just very briefly, I'm emphasizing that networks of compact urbanism are extremely robust. They survive massive disruptions. The example of the massive disruption is in Europe between 400 and about 800 AD. You're looking at typical compact settlements like Roman system, and then through to the medieval world in Europe. You're going from a very stable political structure to extreme instability over a period of several hundred years. But in the milieu of that great instability, there is essentially a great deal of stability in the urban networks themselves. You can have lots of changes in particular settlements, but often the settlements themselves endure. You can have some settlements that die, but overall the networks are very stable. You can see this very clearly in the UK, and there's a nice example of how variable the histories of the places can be, but they actually stay put in their nodes. So the UK is famous for, London is famous for having been a walled Roman town, and then a Saxon settlement developed to its west. Later on, the town moved back inside the old walls of Londinium. This looks like substantial change, but if you locate Londinium in the context of the road network which served it, what you see is that the change is merely flipping back and forth within the frame of the network. The road network itself is extremely stable, and the node itself never changes. So that's just a bit of background. We'll come back to that later. So a couple of bits of background, first of all, is that the key to the discussion that I'm opening is that there is tremendous variation in settlement density. So if you plot hundreds of different kinds of settlements, you plot their population against their density on a standard bivariate graph, what you see is that there is an enormous range from very high densities to extremely low densities. Settlements vary from people being really packed together to being very widely spread out. The contrast, for instance, with the agrarian urbanism is the famous high-density urban settlements like Rome and Alexandria, Chang'an in China, and Edo are up here, and the great low-density settlements like the Maya cities and like Angkor in Cambodia are way down here. There is an enormous range of variation in occupation density. Classic example of a low-density instance, which many of you would be thoroughly familiar with, is the map that the University of Sydney Greater Angkor Project team, collaboration with the French and Cambodians, has produced over the years, is this more than 1,000 square K splodge of occupation on the landscape with complicated communication network, a complicated water network, and an immense engineered landscape for rice production. The density pattern for this type of settlement is that the densities for Greater Angkor in the Angkor region are down here. And if you plot the other settlements for which we have some estimates of population, which Ben Damendra has recently done in his PhD, you see this characteristic pattern of the trend for densities in a low density system is that smaller settlements are denser than larger ones. That's a very distinct pattern, and you see that all over the world. It's in contrast to the classic compact settlements we're familiar with, here represented by the Roman town that is ultimately replaced by medieval Paris. There are lots of studies of the settlement densities in entire regions and societies, this kind of settlement. And this is the characteristic pattern. Classical urbanism, medieval European urbanism, you go from small, low density settlements to big, high density settlements. It's the opposite trajectory. These are very different ways of organizing yourself spatially. You can also see that this is a dynamic process. What you've plotted, what is plotted here in the pale blue lines, is the population trend in the pre-modern world for London. This is a dynamic condition. Very broadly, when you look at the last 10,000 years of settlement growth, you see two very distinct patterns. A high density transitions pattern. This is conventionally what we know as the beginnings of Celticism, early agrarian urbanism, and the Industrial Revolution. And each of those transitions is followed by a drop to low density. After the formation of sedentary agrarian-based settlements, the great shift is towards low density places like Great Savoy in Africa, Cahokia in North America, and Koloa, for instance, in Vietnam. After the initial urban transition, you then get, several millennia later, a drop to low density. And you see that in Mesoamerica, in South Asia, and also in Southeast Asia. And what's happened most recently is that after the industrial transition in the 19th century, we're now in the process but our settlements are generally dropping to low density. All our really big settlements in the world, like the East Coast megalopolis, the great Chinese conurbations, are all at these very low densities down here. That becomes really interesting because just as you can cross-compare these high density trajectories, you can also compare these low to lower density trajectories. And what I'm going to be doing is talking about this group and then discussing them in comparison to our modern industrial cities. So let's have a look at low density dispersed agrarian urbanism. The major cases are located, excuse me a moment, particularly in Mesoamerica, in lowland Mesoamerica, in Sri Lanka, and in mainland Southeast Asia. There are implications now that they're also occurring in Java, and recently I've collaborated with a Vietnamese colleague, Thuy Vo, who has shown that the major cities of the Vietnamese from the 10th century onwards are actually using a low density configuration, of which the familiar, more dense square enclosure form is merely a central component. So let's have a look first at the classic Maya. What we're looking at with the classic Maya running up to 900 or so AD is a major concentration in the southern portion of the Yucatan Peninsula, with some settlements also concentrated further north. These are characteristic low density spread out settlements, beautifully represented in the LiDAR work by Canuto's team. You can see that there is notable big concentration structures in the middle, but then occupation spread out over vast landscapes. Just to illustrate this more generally, is the notable work of the Chases and Caracol, identifying in this enormous area terracing extending over the entire region with a great root network running through the entire complex. If you look at it in terms of the density of occurrence of structures, you can see very clearly this denser central portion, but then scattered, patchy occupation extending out over the entirety of the 200 square K of Caracol. In the middle, you can see the major structures and this very distinct, extraordinary agricultural terracing. This is, in a sense, the epitome of an agro-urban settlement. From the work that Canuto's team did, we now have some idea of this pattern all over the middle portion of the Yucatan Peninsula. The one that has great implication for me is Tikal, because I've actually managed to stand on the top of this, on the platform of this tower here, with Christophe Potier, who I worked with in Angkor, and courtesy of Lisa Lucero and her Guatemala colleagues. This is the central portion of Tikal, just to emphasize the settlement pattern again. You get this patchy occupation, and if you look further into it, you can see widely separated residence locations with presumably agricultural systems associated with those households surrounding. Now, what's become apparent over 20 years of research is that whatever other factors are involved in the demise of the classic Maya, and I would not argue that there is only one of the factors which appears to be a serious destabilizer is the beginning of the medieval warm phase, where there is a period of serious disjunction. It's usually understood in terms of droughts. My sense of it now, in terms of the data that we have for Greater Angkor, Southeast Asia, is that this is actually one of these tremendous unstable episodes of massive rainfall interspersed with severe droughts. There are various very detailed analyses of this condition, particularly from speleothems, and there's a recent study in 2021 showing this band of instability in the period when the classic Maya settlements go down. So what we appear to have is a process of extreme climate instability having a serious impact on the stability of a low density settlement system. Essentially, those great settlements go out of operation. But what is even more significant is that what has happened over the preceding 500 years or more is that a great communication network had developed in the Yucatan Peninsula. And it's essentially an axial system with a maritime component. And what you see is when you go to the classical period, you can see that pattern in the occupation density of the settlements of the classic Maya very clearly. And when you shift to the post-classic, after that environmental change, the pattern of the communication system has changed profoundly, and the dominant location of settlements and in fact of socio-political occupation is round the edges, except for a few cases where settlements are on Great Lakes. So what you see in the post-classic period in this region is that the states and the political and the social groupings have shifted predominantly to the northern end of the Yucatan Peninsula, and the great location of the classic Maya in the south is largely abandoned. What you have is a hinterland urban abandonment, not an abandonment by farmers, but an abandonment by urban systems and urban networks. Now let's move on to have a look at Sri Lanka, where you get low density urbanism commencing in places like Anuradhapura in the center north of Sri Lanka from about 400 BC. What you're seeing in Sri Lanka is that this middle dry forest zone of Sri Lanka contains a group of large settlements. In fact, truly huge. Anuradhapura is probably around 500 square K in extent. We're not entirely clear yet on the exact extent of Polonnaruwa, but I wouldn't be surprised if it's almost the same size. So this is a view over Anuradhapura. It's almost the epitome of the image of these places in tropical forests with great monuments sticking up through the trees. And underneath the trees, there are small shrines, extensive water management systems, economic land surfaces, and scattered occupation zones. This is one of those great shrines in Anuradhapura, the counterpart of those great temples in the Maya settlements. It's a remarkable landscape with these huge water tanks, massive scale of water management, operating in a completely different fashion, incidentally, to the one in the Khmer world. Because in the Sinhalese world, these water tanks are under quite stringent administrative control, for which in Angkor there is no trace at all. So it's this great scattered, patchy landscape with small shrines all across it, occupation locations. This is a detail of that southern portion, showing especially these great tanks which manage the distribution of the water for the rice fields. After the demise of Anuradhapura, there's a shift further to the east to a new capital, which basically took the same sort of configuration. which I've just recently been discussing with Keir Strickland, who's working there at the moment. Polonnaruwa is seated on the eastern side of one of the great tanks. You can see when you go close in on Google Earth, you can see some of those big shrines, the central portion of Polonnaruwa, that it extends much further out across the landscape. Now, the story of Sri Lanka is an interesting one, and it's somewhat problematic. We don't have a climate sequence from Sri Lanka, and there is some indication that the monsoon sequencing may be somewhat different in Sri Lanka to further north, because it's from India, the Indian mainland, that we have speleothem data that tells us what is happening to the climate. The demise of Anuradhapura and Polonnaruwa, this is their end dates, is within the medieval warm phase, with some indication that the way these settlements predominantly operated was actually defined by a drier world than the one that the medieval warm phase operated in, except for this interesting problem that Anuradhapura's demise coincides with a severe blip in the medieval warm phase, which we also see in the monsoon sequence in Southeast Asia, and in which, in Angkor, although I'm not going to elaborate on it, we see a major dam failure. These are just other instances of what is happening in Sri Lanka. The demise is occurring within this medieval warm phase, rather than at its beginning, or in the case of the Angkorian pattern, but they do appear to be associated with marked changes in the conditions of what you see happen in Sri Lanka, whatever the specifics of the impact, socio-political as well as ecological and climatic, is that this great central urban area of Sri Lanka is effectively abandoned by urban systems. There's still farmers there operating at very low regional density, but the urban world of Sri Lanka shifted essentially to the coastal areas of Sri Lanka and down into the mountains to the south. This area in the middle of Sri Lanka was very sparsely inhabited in the 19th century, when British administrators began to investigate the piece of territory they'd taken over and discovered that in this region there was clear physical evidence of enormous facilities for producing rice. And so they promptly decided to resurrect the rice economy in this landscape. Finally, to come to my third example, mainland Southeast Asia, and the work we've been doing for 20 years now on Greater Angkor. First of all, it's very important to acknowledge the international teams we collaborate with, both APSA in Cambodia, the FAO in France. The FAO has worked for more than a century in Angkor, generally in Southeast Asia. Also, to acknowledge that this has been work which has been very substantially funded by the Australian Research Council. So we're looking at a settlement system that developed from the 7th century onwards and has its demise somewhere in the 14th century, as its peak between the 9th and 13th. You've seen the version of this image before. This is Damien Evans's updated map of Greater Angkor. Greater Angkor is this splodge on the landscape, about 1,000 square kilometres of distributed water tanks and shrines. It has an interesting history. Its initial development is a series of separate settlements, one that is now largely buried because the West Barai of Angkor was built on top of it, called Bhavapura, so drastically built on top of it that the state temple of that urban area is now inside the bank, West Barai. The site of Haraharalaya off to the southeast, and a settlement, a very brief settlement, was never finished up on the top of the Tulen of the Henry. This was abandoned, and what then happens over the following 500 years is that you get initially a concentration in the center here that links the two separate settlements into a triad, and you then basically get the formation of a multi-centric urban complex with this great network of canals and a landscape that is intensely utilized for agriculture. This is a huge phenomenon. There are 4,000 or 5,000 water tanks in the place. There are several hundred shrines. Most of the shrines you see here are pretty much the size of the equivalent of a small parish church. The really big ones, the big 7 or the big 15, however you define them, are in the middle here, including particularly Angkor Wat, which is that. The thing to bear in mind is that for all the focus on the great temples in Angkor, most people are living in this landscape. They're living in these great sprawling outer suburbs of residential clusters of occupation mounds built around water tanks and around shrines. This overall is a rough image of what that landscape would have looked like. When we did the initial radar surveys of the center of Angkor in the early 21st century, one of the things we noticed was this extraordinary blue pattern in the multi-radar. And when you look at it closely, you can see here to some degree and here, there's a grid pattern. And that grid is the Angkorian field system. The Angkorian field system had very wide bunds around the rice fields. The bunds are about 1 meter wide, which is an indicator that they were a significant part of the communication system. This is quite an extraordinary landscape because you can even see this with your own eyes when you come in and out of the airport. So these are the Angkorian fields, and these thin lines are the modern fields lying on top of this. There's no depth to this at all. They're sitting right on top of each other. The reason why you can see the Angkorian fields in the radar is that the old fields are just slightly lower than the remnants of their bunds, and they retain water. And that is a very strong signal for radar and for light. So we have several thousand square kilometers of intensely managed landscape. This is the latest system of those rice fields. It's an orthogonal rice system right in the middle of Angkor, which you can also see interpolated into it much older rice field systems with ancestries going back probably even before the 7th century. And these are commonly aligned on the alignment of the local shrines. The only other point I want to make about this system before we go on to the issue of its demise is the sheer scale of the thing. This canal here is 25 kilometers long. This canal runs for more than 40 kilometers across the landscape. This is a highly organized system, effectively with no moving parts. Water comes in on these dark units from the north. It's held in these great reservoirs, and then from those holding tanks, it's either dumped down to the lake, which is down these canals, or it's distributed along these canals in order to be spread out across the rice fields. So this is both a very sophisticated and a very simple system. It's very sophisticated because there's very little gradient. in this landscape. Give you some idea again of scale. That's that 25-kilometre long canal coming down to the north side of Angkor Thom, right in the middle of Angkor. To give you some idea of its sophistication, but also of the precision with which it's managed, which is very serious for the problem of its demise, is to look at this location where the off-take canal removed water from the Siem Reap River coming down from the Kilometres. So it's that junction there of the river and the Great Canal. This is what it looks like in the LiDAR. That's the river valley there, and this is that huge off-take canal. It turns out when you look closely, there was another channel, and this is a channel for dumping surplus water off to the east. But in the original configuration of this in the late 9th and the early 10th century, there was a masonry dam across what would have at that time been a relatively narrow valley. So it was blocking this valley. The water came up against that dam and then ran down this great canal to the south. The problem for a configuration of this sort is that what you are at risk of for the engineers is that too much water will try to go down this channel. And this dam, of which not very much remains because it did at some point fail in the 10th century, is that it is brilliantly organized to manage overflow. The cross section of the dam is a steep slope on the upstream side. This is where the water comes in, and a long masonry slope down to a really sturdy edge structure in the west. And at the top, there is a coping stone. We were very fortunate in our work to find that coping stone. This is the slope, that's the slope here, and that's the coping stone, and that's a view of the edge of that coping stone. The significance of it is that that point, right there, at that change from one slope to the other, is this here. And that is the level at which water coming down the river would have begun to overflow and would not then have gone down the Great Canal to the south. The significance of that is that that point there sets the water level at which the rest of Angkor to the south operates. That governs the water level going down slope through the rest of the city. This is an enormously precise system. Its problem, of course, is that it is devised in the context of the medieval warm phase, which, though it contains fluctuations, as you saw for Sri Lanka, is relatively stable and relatively warm. The great pinnacle of Angkor's existence runs precisely through the time span of the medieval warm phase. Notice that the Mayan cities are going down in precisely the context in which the Khmer cities are rising. Temperature rise or fall is a disaster for some people, and it's an opportunity for others. But when you get through to the 14th century, the world is shifting from the medieval warm phase into the Little Ice Age. And any of these great temperature transitions, as we experience now, is a period of increasing climate instability. And that climate instability was identified by Brendan Buckley's team working in Vietnam, where they found a relatively rare tree in Southeast Asia, which has strongly differentiated tree rings caused by a relationship to water. On the whole, tropical trees are not particularly useful for this. But what you can see really clearly in the tree rings from pine tree in Vietnam is that there's a period from about the 1300s until almost 1500 in which there is this extreme instability in the system. You're going from mega monsoons to mega droughts. This range of variation, which you see defined by these two brown lines, is far greater than the range of variation in the monsoon since 1500. This is a period of extreme instability. It is in this context that you have the last of the Angkorian inscriptions and the first of the new tradition of inscriptions, and then the re-establishment after the demise of Angkor of the royal house of the Khmer, utilizing Angkor Wat again. In this period here is where you see the demise of Angkor. There is a comprehensive breakdown, network breakdown through this entire central canal system, from the rupturing of the dam at Bampton Riak through to really severe erosion in the center of the city, which you can see really clearly in the LiDAR in the area just to the east of the northern edge of Angkor Thom. So the next image is a view from the east looking west. So you're looking from the east towards the west. This is a great dam which is completely ruptured, and this is the level of the erosion which has gouged its way down through the middle of the city and torn out whole portions of the occupation, resident occupation in this area. It had two effects, one in the Great Canal in the middle of Angkor and the other down in the south. The effect in the middle of Angkor was to gouge out the canal to about 5 meters below its original level. This is from the LiDAR data. This is roughly the ground surface today, which is very close to the level at which the Angkorian canal used to flow. And this here is the current level of the river. This is a devastating scale of erosion. It's a vast amount of deposit, which then proceeded down the channel, and it arrived in the areas near the lake where the landscape flattens out. And at that point, the water lost its energy, and the sand and the debris dropped out of the water and completely clogged up the big southern dams. So this here, this slope here, is the eastern bank of a canal going north-south down to the lake, and this is that sand fill. The whole canal was just filled with stuff. In that fill, there is vegetation. It's preserved because water is flowing down through the sand. You can see how coarse the sand is at the back here. And that gives us radiocarbon dates which correspond very closely with that period of severe instability represented in the data from the dendro data from there. You can see then from the C14 dates of the occupation of the great temples that in the Ta Prohm, for example, occupation ceased by 1400. And in Angkor Wat, there is a serious glitch in the occupation in that same period. Angkor Wat has actually never been abandoned, but there was a serious occupation glitch in the 14th century. In other words, there's a severe impact on the viability of Greater Angkor. The reason for that is very simple. Once this great system is ruptured, it breaks all the capacity to move water from east to west in the north and from west to east in the south. It essentially prevents the system from providing the water that it could otherwise have previously provided for circumstances of severe drought. And what you find very rapidly is that the 14th century occupation of ceramics is still quite extensive. It's diminishing, but it's quite extensive. And by the 15th century, occupation has dropped almost entirely down to the area around Harahara to the south. You are seeing, in essence, the demise of the greatest low-density city of the pre-industrial world. What you then see when you look at the communications system is that the Angkorian world had a titanic system of roads. These are massive road embankments, and there are subsidiaries which come off them. That's the pattern at the peak of the Angkorian world. By the time you get to 1800, when the Thai royal mappers are making a record of the territory around the Tonle Sap, which is their representation of that lake here, with Angkor just being there, there is no trace of this route system. It has been entirely replaced by a network that is going in a completely different direction. The great route network and all its connections is gone. What you also see very clearly in the convention of the Thai maps is that the location of Angkor, which is here, is represented only by names of temples, and these red marks are the locations of towns. This is completely different to our mapping convention. That's up in the Isan Plateau, that's way over to the west, and this is down the Mekong. So this is what that pattern looks like. Angkor in the middle, this central area, this heartland has effectively been abandoned by urban systems, not abandoned by farms, but abandoned by urban systems. And the urban world, as it reconstitutes itself over the following 400 years, moves to the south of the lake and around and up the Mekong, and then ultimately back across the Assam Plateau. In other words, the heartland has emptied out and the urban world has moved outwards to reconstitute itself. So if you look at these three cases, in the Maya world, you go from a concentration in the middle to settlements around the periphery. In Sri Lanka, you go from a location in the central area to occupation around the periphery. And in Cambodia, you have a concentration of heartlands of the north of the lake. And after the demise of that urban system, you get compact settlements reconstituted much further. So what's the significance of this? The implication is that in a major low-density urban system, extreme climate instability is very damaging. It is liable to take out the primary infrastructure and the primary operating base of low-density urban settlements. But it's more severe than that. It's not just that a particular settlement like Greater Angkor ceases. There seems to be some very considerable connection between a low-density system and all of the rest of the urban network associated with it. And when some of the network begins to fail, it appears that the whole network goes down. What is important to note is that this is not a simple statement of, oh, you have the collapse of civilization because of climate change, because that's not the case. In Cambodia, for example, it would not be very wise to stand in the street and tell the Khmer that Khmer civilization collapsed, because there's no evidence that it did, and the Khmer would be quite annoyed at any such proposition. Greater Angkor disappeared. There was demise of a great urban system, the largest, most extensive at the time. But the socio-political system of the Khmer survived. It moved sideways from Angkor to Phnom Penh. It kept its identity, A century later, it moved back and was renovating big temples like Angkor Wat in Angkor, even though the urban system was gone. And that integrity, cultural integrity, political integrity has been maintained ever since. So you can go through a serious disruption of this sort and your socio-political system can survive. It might not. The one for the classic Maya didn't. And the one in Sri Lanka was seriously destabilized and reconstituted. So why does this matter? Well, it matters because in our world, we are moving to living in great, sprawling, low-density, multi-centric conurbations, or what are called in Eastern Asia, Southern Asia, Desakota, rural urbans. This is Greater Shanghai. That's Shanghai, just there. But Greater Shanghai is now this huge area that extends almost as far and probably now does include Nanking. It's made up from many older, smaller settlements, which began to expand through the 1990s into the early 21st century, and have then formed up as a single integrated entity since then. This is what has happened to the overall density pattern. You can see that you go from high density, small settlements through to enormous, much lower density settlements. And most of these figures, I suspect, are actually much lower. You see the same in the States. This is the East Coast megalopolis in the States. That's its growth pattern on the left-hand side. What is significant on the right is its structure as a commuting landscape. And what you can see is that there are huge areas of the landscape which deliver people, labor, supplies into these central areas. And I suspect that somewhere in this, you're seeing something of this indication of the connection between a rural world or a hinterland world and one of these low density concentrations. It's an interesting problem because this appears to contrast somehow with the configuration of a network of discrete, compact settlements. You can see broadly what has happened in that landscape just from the density pattern of New York. It rose to very high density in the late 19th century and was plunged down to extremely low density, the low density of the whole East Coast megalopolis in the 21st century. On that diagram I showed you earlier, the IC matrix, as I call it, this is where the low density agrarian urbans are. So Angkor is somewhere in here. That's the pattern of the density trend for those agrarian low density settlements. And this is the distribution of the densities associated with industrial low density urban settlements, megalopoli, Desakota. What you can see very clearly is this huge drop to these low densities beyond an area of about 10,000 square kilometers. And this is the worry. Because if it is the case that low density dispersed settlements create networks which are not resilient in the face of severe climate change, we have something to be worried about. These are the great disruptors for Mesoamerica and for the Khmer, with the interesting issue of what is going on in Sri Lanka, which needs a great deal of further analysis. The point to notice is that you can be badly affected on a temperature rise or a temperature drop, and we are currently in the process of a very substantial temperature rise. When you look at it in terms of where the anomalies are on the planet, serious temperature anomalies, the real changes, are occurring in this band across the Northern Hemisphere, particularly associated with North America, Europe, and over Asia. And that is exactly where the great low-density megalopoli and desiccata of our world are located. If it is the case that severe, extreme climate instability can unstitch these low-density places, which you can easily envisage for all of these because they're all at sea level, and sea level is one of the things that is going to rise, and it would, for instance, in New York, swiftly take out the underground system of New York. If we're going to see these systems come under serious threat, if they fail, the pattern that we would be seeing in the future would be that loss of a heartland and the process of settlement systems moving outwards away from those low density concentrations to reconstitute a new urban world. Remember that image of the pattern from Angkor down to the Mekong south of the Tonga. You would have the old urban world replaced by a new outer circuit of compact settlements. If I was going to give you a long-term recommendation for real estate, I'd invest in Mumbai, which is quite well above sea level, but particularly in Mexico City, would be a very good option. What is serious about this is that no modern low-density city has its ancestry in an agrarian-based low-density city. These low-density cities derive from the high-density transition of the Industrial Revolution, not from these low-density systems. These low-density systems derive from the transition to dense agrarian urban. What is even more serious is that there is another group of low-density settlements on this planet, as I mentioned earlier, represented by places like Great Zimbabwe, Cahokia, and there is no connection between these and these. There's no simple link from this smaller settlement size group to this bigger agrarian, conventional, urban literate system. This group, in turn, have their ancestry in the initial development of sedentary systems in some fashion. We don't fully understand what this process is. But what is worrying is that this has no future, and this has no future. And that suggests ominously that this would have no future. By contrast, at high density, you have an endless stream of transformation and change. Thank you very much. Now I've got to get out of this. Okay, thank you very much.
Thank you very much, Roland. That was great and exhaustive. So
if you go there, I'll check the chat.
Right. So yeah, if there are any questions now, the chat is open for you to post the questions. But otherwise, I'll start with a question on specifically maybe Rome as an example that you used as a high urban settlement, because that also, to me, it seems kind of is sprawling out. It seems to be the trend throughout kind of Europe and North America to start making these sprawling cities. So in this case, would Rome also fall under this idea of, or not idea, of a place in danger of kind of dispersal?
In the Roman period, no. Rome's really chunky. It's a very, very rugged, long-lasting place. You know, it's a classic example of this higher density configuration where you can go from a village ancestry to a small town until eventually you become an imperial capital, then you have a rough time, and then eventually you transform into an industrial city. It's now dropping to lower density, but it's not at an exceedingly low density, just as Sydney is not yet. But I would mention something to you. There was a very interesting issue arising at a meeting several years ago in Rome. A colleague of mine asked me why Rome isn't a low density city. And that's now going to be the basis for an initial project to ask why Rome in the Tiber Basin is not the same type of configuration as Angkor in the Angkor region. And it was a very significant question for Simon Malmberg in Bergen, because what it will do is it will lead us ultimately to the issue of how do you define what the edges of a low density settlement are, and how do you answer this question of what is the difference between a low density system and a compact system, other than us just looking at the numbers. So thank you for the question. It's a highly consequential issue. It really matters. Did I answer your question?
You did, but I'd follow up with, what about when these kind of, because you do have the core, for example, of these very old cities, which in some cases are extremely high density, but when you're kind of, but I know you're looking at a big picture where the, so to say, in some cases, the outskirts lower the density of the whole.
Yeah.
So what happens when these changes occur? What happens with the high density core of these?
Well, the really striking thing is that it can move around. The histories of the towns of Europe in the post-Roman period, which a student of mine has just been working on, are extremely varied. The centers can move sideways, they can go back and reconstitute themselves. There's an enormous variety. And to come on to another question, this is the big issue of what is the relationship between a settlement and its hinterland. The implication of an initial study of the Roman context in the British Isles is that the settlements which endure in the network are the settlements with very substantial local hinterlands, as if the robustness of the system is actually inherent in a hinterland which is somewhat independent of the dense settlement which is in the middle. And that really requires an intense amount of investigation, because one of the points I've been making for some time about Angkor is, and the Mayan cities and also the Sri Lankan ones, is that you can't really talk about an agricultural hinterland of Angkor that's inside these low density systems. It's not a hinterland. It's actually part of the operating system of the city. The hinterland of Greater Angkor is beyond its 1,000 square K and extends then for thousands of kilometers across the landscape. And it's there, somewhere there is this clue to what it is that makes the low density urban network system fragile. So thanks for the question. Now, just before we continue, could I do something, please? Margaret Deeth. that I say hello to you. And I'd like to acknowledge Margaret because she was the editor for The Limits of Settlement Growth, for which she really deserves sainthood because it was a monster to deal with. Margaret, I'm deeply grateful to you. Thank you very much.
Good to see you.
Good to see. I can't see you, unfortunately, but marvelous to see that you're here. Thank you so much for coming.
Cheers.
I hope to see you in Cambridge one day when I come back across the world.
Right. It's a day.
Please take care. Sorry to interrupt.
No worries, no worries. Katie Campbell has a question.
Hi, hopefully you can see me and hear me.
Yeah.
Thank you very much. That was really, really interesting. And actually, I think you already sort of started to answer my question in the second half of your answer to the previous question, which is, I work mostly in Central Asia, in the Middle East and in the medieval period. And I think we're sort of slowly beginning to understand this relationship with hinterland, and especially in terms of how nomadic groups are feeding into the urban economies and the kind of relationship between, the really important relationship between not only nomadic groups in the kind of hinterland of the cities, but also quite far away, you know, on the steppe, and really long-term, long-distance relationships between these groups, which aren't always easy to find in either historical or archaeological evidence. And I was wondering about the spaces in the city. And I think we have some evidence now that there's a certain amount of temporary occupation, you know, camping, things like that, that might not be visible from LiDAR or other ways of archaeological investigation to look at sort of the whole city. And I was wondering how flexible you thought this low density setup is, and whether that could provide some protection or otherwise. So it's a slightly amorphous question, but I just wanted to get your take on that sort of relationship there. Thanks.
It's a very important one because there is a sense in which low density systems seem quite adjustable. They do quite well for quite long periods of time. The addition, which is really important coming from what you're saying, is that on that interaction communication matrix, which I use, what is really significant about these low density systems is that they lie in a band which coincides with the other mobile settlements of the world, mobile communities. So for instance, there are these huge Ethiopian moving capitals with 30 to 40,000 people shift around in the summer. Now, thinking about that led me to think quite seriously about the mechanics of Angkor, because we know perfectly well that for 4 or 5 months in the middle of the year, somewhere on the order of 100 to 200,000 people came in from the countryside to build stuff in Angkor. So somewhere on the order of 1/7 of the population of Angkor appears and disappears in the course of a year, which begins more and more to indicate that we have to have a rethink of mobility in terms of whether the workings of the settlement substantially depend upon a key portion of its population moving in and out in the course of the year. So that whole idea of people moving into a place like Karakoram for a short period of the year, or coming down to the big coastal towns off the steppe, becomes really important. That what we may have to do is vastly extend our concept of mobility beyond our usual understanding of people using hunter-gatherer economies or pastoral economies, to actually how substantial the mobility of a significant portion of the population is in and out of what we have conventionally thought of as purely sedentary communities. And I think that would be a really major issue to pursue. I would think the two huge issues in settlement analysis now are what to do about mobility And the other one, which relates to the other point we made, is we need some scaling analysis of hinterlands, some way in which we can get people connected to talk about hinterlands from a relatively small scale right up to an enormous scale, and that it would be really worth us being able to cross-compare those different magnitudes. So that I suspect that work on the pastoralist systems of Central Asia is going to be critical to both those questions. But it's a really important area of new research.
Great, thank you.
Pleasure.
Do we have any other questions?
Is there anybody for last question? I think we're getting closer to the end of the time. If not, then I'll ask a very, very quick question, Roland. Thank you so much, inspiring as ever.
Pleasure.
Where do we go and live? Do we go to Shanghai? Do we go to the East Coast of the United States? Or where do you think the urban resilience lies in the future?
Oh, my suggestion, if you're investing in real estate over the next 200 years, I would buy in Mexico City. Sea level isn't going to touch Mexico City. It doesn't matter how big or spread out it gets. Mumbai is up on the, half of Mumbai is up on a nice big cliff, so it'll do all right as well. I don't know whether you're asking me about real estate investment, but you should never take my advice, or about going on holiday.
No, I was generally, I guess, but no, it was more about the type of forms that you think will make it. I mean, the types of forms of urban forms that will weather climate change and will persist over time.
Well, my judgment will be that societies on this planet which are using predominantly compact systems, however badly they are battered, will retain the coherence of their settlement system. The issue I think we have to consider very seriously in the industrialized world is whether we are going to ruggedize our low density cities, or whether what we should be doing now, and it's been discussed by some scholars in the States, is whether we should start creating an outer arc of compact settlements. For instance, in the United States, way across towards Atlanta and so on, that would be available where people could move if there is a serious breakdown in these low density systems. Because the core problem we face, and it's an instance of what is locked into these low density settlements, you can't re-densify a low density dispersed system. In our world, if you tried to do that, you would have to dispose of huge quantities of investment in land property, and you would ruin the banks and you would ruin the middle class. We simply can't do it. We can't chop up large dispersed cities into their former compact nodes. So we've either got to work out some way of protecting them against climate change, and or we've got to work out some backup. But if things go wrong, there are places for people to move to. Those would be the serious implications of this, and they're both on a huge scale that I don't think any national government would incline to deal with at the moment.
Thank you very much.
Pleasure. Thank you very much, Federica.
And before we all let you go, so next week. Oh, right, yeah. So let's give another warm thank you to Roland Fletcher.
Thank you.
Inspiring talk.